All right, 62. Give the y coordinate. All right. This is set up for elimination, correct? Do you agree? And they want the y coordinate. So which variable should we eliminate? The x, right? So let's multiply the top equation by -4 and the bottom equation by 3. So that'll give us a 12 and a -12 for our x coefficients. Those will be eliminated. So the top equation will give us -12x minus 20y is equal to 16. The bottom equation, when we multiply it by 3, will give us 12x plus 9y is equal to -27. If we combine those two equations now, the x's get eliminated. That gives us 11y is equal to -11.
Wouldn't it be negative 1?
Yes, thank you. So y is equal to 1. Yes, ma'am.
Could you use substitution for it?
You could. You're gonna get some fractions though, won't you?
What's that?
Yeah.
Huh? Yeah. Yeah, you can, substitution or elimination, you can both, use them both.
When you're doing the matrix thing,
Yes.
how do you set up? I thought it was like a squared b. Like when you set up like the arrays already.
To calculate your answer,
Yeah.
it's A inverse B,
Oh.
the little -1.
Yeah.
Are you doing this one with the,
Yeah.
you know this is the non-calculator section of the review, don't you?
I know. I just want to remember how to do it.
Okay. Yes, sir.
If we need to find the x coordinate, will we just plug the y value in?
Yeah, now you can just plug the y into either one of these two equations and solve for x.
Okay, so it doesn't matter which one is
Nope.
either. Okay, this one.
Any other questions on this one? No. All right, 63. Give the slope of the line perpendicular. Perpendicular to 5x plus 2y is equal to 12. So what do I know about slopes of perpendicular lines?
Opposite reciprocal.
They're opposite reciprocals, right? So I need to find the slope of this one first, and then take the opposite reciprocal of that, and here we got our answer. So I'll put it in slope-intercept form. So minus 5x to both sides. 2y is equal to -5x plus 12. Divide everything by 2, so you end up with y is equal to -5/2 x plus 6. So the slope that would be perpendicular would be
2/5.
2/5. Very good. Any questions on that? All right. 64. Use the discriminant to tell how many real solutions each equation has. What the heck's a discriminant?
B squared.
What?
B squared minus 4AC.
B squared minus 4AC, right? Where do we see that from? Normally. It's it's what's inside the square root, right? The quadratic formula, okay? So if we plug these values in, we'll end up with -4 squared minus 4 times 5 times a -3. So I've got 16 plus 60. So that's 76. Positive 76. So use the discriminant to tell how many real solutions each equation has. I got a positive discriminant, so what does that mean?
Two.
Yes, 2 real solutions. All right, 64B. Any questions on that? Yes.
Is it like a rule or something?
It's a rule, yeah.
What's the rule?
If the discriminant is greater than 0, positive, you get 2 real solutions.
What if it's not?
Well, which choice are you talking about?
What if it's like not greater than 0?
So are you talking about 0 or less than 0?
Both.
Well, if it's 0, there's 1 real solution. If it's a negative number, it's no real solutions.
Alright.
Which makes sense if you think about where this is in the quadratic equation. It's a square root, right? So if this ends up being a negative number, what do you have?
High.
You have imaginary answers, no real solutions, if this is negative. If this is 0, square root of 0 is just 0, right?
Yep.
So you just end up with negative b over 2a as your answer, your one answer, if this is 0. Because the plus or minus then wouldn't count for anything. Okay? Christian, that answer your question?
Yes, sir.
Okay. Yes, sir.
When you're looking for how many real answers, can you just look at the highest exponent and would that be the amount?
No,
Or is that for something else?
just that's complex answers.
Oh, okay.
How many total answers you're going to have. That doesn't tell you if they're real or imaginary. You see what I'm saying? All right, 64b. 6x squared minus 12 equals 0. So I need to do b squared minus 4ac. What's my b in this?
0.
0. So 0 squared minus 4 times 6 times a negative 12. I'm not sure what that is, but it's positive, isn't it? It's a positive answer. Everybody agree with that? So 2 real solutions.
So, oh, I see why the table is there.
Yes.
Okay.
All right, 64C. So I got negative 4 squared minus 4 times 5 times 3, 16 minus 60, negative 44. I got a negative discriminant, no real solutions. What would this graph look like if we were to graph this? In general, what would the shape be? A parabola, right? Opening up or down? Up. Would it touch the x-axis? How do you know? All right, let me tell you this. The real solutions are found where the graph touches the x-axis.
So what if,
This graph touch the x-axis? Wouldn't. If it touched the x-axis, you'd have real solutions. So this may look like something like this. So if the graph doesn't touch the x-axis, you know there's imaginary solutions. No real solutions. Okay?
okay,
It's important.
the
It's like 64D. All right, 65. Solve 2x squared minus 24 equals 0. We can add 24 to both sides. 2x squared equals 24, divided by 2. X squared is equal to 12. Take square root of both sides. X is equal to plus or minus 2 root 3.
Mm-hmm.
Any questions on 65?